Now we're going to discuss more ideas and more examples on the limit of a function to infinity. Theorem 5, where the limit as x tends to infinity of 1 over x is equal to 0, and the limit as x tends to infinity of a over x is 0, and the limit as x tends to infinity of a over x to the power n is 0, where n is positive. We use theorem 5 and its corollaries if the direct substitution gives infinity over infinity or infinity minus infinity, and let's see the first example. Here we want to find the limit as x tends to infinity of 2x plus 3 over 4x squared minus 5 over 3x squared minus 8 times 5x minus 3. First, we need to find the highest power of x in the denominator. We have two factors here. So this is multiplied by this, and also this is multiplied by this. So here the highest power of x for the first factor is x squared, and here we have x. So the highest power of x in the denominator is this times this. So x squared times x, of course to the power of 1, is x to the power 2 plus 1 to be 3. So x to the power 3. What we're going to do now is to divide both the numerator and denominator by x to the power 3. For the numerator, it's also two factors. We have two factors, and we need to divide by x to the power 3. And the same thing for the denominator. We're going to divide each term of the denominator by x to the power 3. So this is equal to limit as x tends to infinity of. Now, for the first factor or the first bracket, it has x to the power 1. It has only x. So let's divide each term of the first factor by x. So 2x over x plus 3 over x. The second term, it has x squared. So let's divide each term by x squared. So 4x squared divided by x squared and minus 5 divided by x squared. So finally, x times x squared to be x cubed. Same thing for the denominator, but let's start by power of 2, because the first term has power of 2. So 3x squared divided by x squared minus 8 over x squared, and here 5x over, now divide by x, and minus 3 over x. Now x squared times the x to be x to the power 3. Let's simplify. This is equal to limit as x tends to infinity of 2x over x to be 2 plus 3 over x and times 4x squared over x squared to be 4 minus 5 over x squared, and here 3x squared over x squared to be 3 and minus 8 over x squared, and this is times 5x over x to be cancelled, so 5 minus 3 over x. By the theorem and its corollaries, 3 over x is 0, 5 over x squared is 0, and limit as x tends to infinity, of course, of 8 over x squared is 0, and this is also 0. So finally we have 2 times 4 to be 8, and down it's 3 times 5 to be 15. Now number 2. Up we have two factors, and down also two factors. Highest power of x in the denominator is x to the power 5, and for the second factor we have only x, or x to the power 1. So x to the power 5 times x to the power 1 to be x to the power 5 and 1 to be 6, so x to the power 6. Now you're going to divide each term of the numerator and denominator by x to the power 6. We need to distribute this x to the power 6 among the two factors. The first factor here has power of 4, so it takes power of 4. So the second factor here has power 2 as the highest power, so it takes power 2. So here we're going to divide by x to the power 4, and here x to the power 4, and here x squared, and here x squared, and here x squared. Same thing for the denominator. Now x to the power 4 times x squared to be x to the power 6. For the denominator, we're gonna divide here. Here this has x to the power 5 and this has only x. So we're gonna divide the first factor by x to the power 5. Each term. Let's cancel this. And here we're gonna divide by x, only x. Now x to the power 5 times x to be x to the power 6. Now let's simplify. This is equal to limit as x tends to infinity of. Now x to the power 4 is cancelled. So 3 plus 5 over x to the power 4 times 2. X squared over x squared cancel each other. So 2 minus 3x over x squared. Subtract the powers down. So it's 3 over x to the power 2 minus 1 to be x. And plus 4 over x squared. Down it's 2x to the power 5 over x to the power 5 to be 2 minus 3x over x to the power 5 to be 3 over x to the power 5 minus 1 to be 4. So x to the power 4 and plus 1 over x to the power 5 times x over x to be 1 plus 7 over x. Finally, by the theorem and its corollaries, limit as x tends to infinity of 1 over x is equal to 0, or limit as x tends to infinity of a number over x to be 0. So by the theorem and its corollaries, this is 0, this is 0, and this is 0. This is 0, and here 0, and here 0. Now we have 3 times 2. So 3 times 2 to be 6, and down it's 2 times 1 to be 2. So 6 over 2 to be 3. Example 3, the limit as x tends to infinity of 2 plus square root x and times 5 minus 2 square root x over 8x minus 4. Highest power of x in the denominator is x. So x to the power 1. So we're going to divide each term of the numerator and denominator by x. In the numerator, we have square root x. Once the square root appears, so we need to change x in this form. So square root of x squared is equal to x. Like cubic root of x cubed is equal to x. And fourth root of x to the power 4 is also equal to x. So let's divide the terms of the denominator by x. For the numerator, we have 2 factors. So square root of x squared means square root of x times square root of x. That's what we are going to do. We're going to divide each term by square root x. So here by square root x, and here by square root x, and here divide by square root x, and here by square root x. So square root x times square root x to be square root x squared to be x. Now let's simplify. This is equal to limit as x tends to infinity of, so 2 over square root x plus 1 square root x over square root x to be 1, close the bracket, and times 5 over square root x and minus 2 square root x over 2 square root x cancel each other, so minus 2, and down it's 8, x over x cancel each other, so it's 8 minus 4 over x. Square root x means x to the power 1 over 2. So square root x means x to the power 1 over 2. So this is equal to limit as x tends to infinity of 2 over x to the power 1 over 2 plus 1 and times 5 over x to the power 1 over 2 and minus 2, and down it's 8 minus 4 over x. So by the corollary, if we have limit as x tends to infinity of a over x to the power of n, this is equal to 0, and n should be positive. So this is 0, this is 0, and this is also 0. So finally we have 1 times negative 2 to be negative 2 and down it's 8, so this is equal to negative 1/4.